Hello dear students, welcome back to the session. In the previous session we discussed about the total capacitance or effective capacitance of number of capacitors which are connected in series. Means we have determined effective capacitance of the number of capacitors which are connected in series. In this session I will go for the parallel combination of what? The capacitors. Means we are going to determine total or effective capacitance when the number of capacitors are connected in parallel. Write on the next title here. Parallel combination of capacitors. Parallel combination of capacitors. So that is we are going to determine total capacitance when the number of capacitors are connected in parallel. So as I discussed in the last session, that is, in order to get minimum capacitance, we are connecting the number of capacitors in series. When if we use series combination of capacitors, the purpose of using the series combination of capacitors is to get minimum capacitance out of number of capacitors. So in which situation you are going to use parallel combination here? Suppose if you are expecting maximum capacitance from number of capacitors, ನಿಮ್ಮ ಹತ್ರ ಕೆಲವೊಂದು capacitors ಇದ್ದಾವೆ, but you are expecting the maximum capacitance out of those capacitors, then we are connecting the capacitors in parallel. When the capacitors are connected in parallel, the total capacitance of the combination is going to increases. Or else in general, in order to get the maximum capacitance, the number of capacitors should be connected in parallel. Okay, let me take a parallel combination here. I have 3 capacitors, or else you can take even 2 capacitors here. I have 2 capacitors. First capacitor of capacitance C1, second capacitor of capacitance C2. They are connected between 2 common points. They are connected across 2 common points. One point is A and another point is what? B. So these 2 capacitors are said to be connected in parallel because the 2 capacitors are parallel to each other. Such a type of combination we will call it as a parallel combination of the capacitors. First capacitor of capacitance C1, second capacitor of capacitance C2 are connected in parallel. Across this combination we are going to apply potential difference. So V is a potential difference which is applied across the combination. With the help of the battery we are going to what? Apply the potential difference V. As a result, the capacitors will start storing the charges. Purpose of connecting the battery is to give charge to the capacitor. Now the capacitors are going to store the charge. So very interestingly, when the number of capacitors are connected in parallel, they are going to store different charges. That is, charge stored by first capacitor will not be equals to charge stored by what? Second capacitor. But in case of series combination, when the number of capacitors were connected in series, charge stored by all the capacitors were same. Series combination alli ella capacitor same charge na store ಮಾಡ್ಕೋತಿದ್ವು. But in parallel combination alli ಏನಾಗುತ್ತಂದ್ರೆ charge stored by the capacitors will not be same here. Different capacitors are going to store a different amount of charge, but very interestingly, potential difference across the capacitors when they are connected in parallel is same. Concentrate this point. When the number of capacitors are connected in parallel, potential difference across each capacitors will be same. Further, that potential difference is equals to potential difference of the battery. For example, with the help of the battery, suppose if you are giving 10 volt of potential difference, battery connect ಮಾಡಿ ಒಂದು ವೇಳೆ 10 volt ಏನಾದರೂ potential difference ಕೊಟ್ಟರೆ ಅಂತಂದ್ರೆ, if you measure the voltage across C1 and you measure the voltage across C2, voltage or potential difference across C1, voltage or potential difference across C2 will be same, which is equals to what? How much voltage you are giving. ಇಲ್ಲಿ 10 volt ಕೊಟ್ಟಿದ್ದೀರಾ, C1 ನಲ್ಲಿನೂ 10 volt ಇರುತ್ತೆ, C2 ನಲ್ಲಿನೂ 10 volt ಇರುತ್ತೆ. In general, the potential difference across each capacitors will be same in case of which combination? Which combination? Parallel combination. But charge stored by the capacitors will not be same here. That is, Q1 is a charge stored by first capacitor. Definitely Q2 is a charge stored by what? Second capacitor. Q1 is a charge stored by first capacitor. Q2 is a charge stored by what? Second capacitor. In such a way that total charge of the combination is equals to sum of the charges stored by individual capacitors. This condition is going to satisfy for parallel combination of what? Capacitors. ಸ್ವಲ್ಪ focus ಮಾಡ್ರಿ. When a number of capacitors are connected in parallel, potential difference across each capacitors will be same, that is equals to V, but total charge of the combination Q is equals to sum of the charges on individual capacitors. ಒಂದು ವೇಳೆ 3 capacitors ಇದ್ರೆ Q is equals to Q1 plus Q2 plus Q3 ಇರುತ್ತೆ. If n number of capacitors are connected in parallel, then Q is equals to Q1 plus Q2 plus Q3 up to Qn. So this is the condition for what? Which combination? Parallel combination. I will call this as equation number 1. I am going to derive an expression for total capacitance when the number of capacitors are connected in parallel. Okay, help me to derive the expression. So Q is equals to Q1 plus Q2. In the next step, we will try to substitute the value of what? Q1 and Q2. So we have the formula here. We know that what? C is equals to Q by V. C is equals to what? Q by V. This implies what is the value of Q? Q is equals to CV. C is equals to Q by V. Therefore, Q is equals to what? CV. This implies what is Q1? Q1 is equals to C1V and Q2 equals to what? C2V. Why we are taking V for Q1 as well as Q2? Because potential difference across first capacitor is equals to potential difference across second capacitor. Therefore, what is the total charge? Total charge Q is equals to CV. Charge on first capacitor is Q1 is equals to C1V. Charge on the second capacitor is Q2 is equals to C2V. Substitute those values in equation 1. Substitute in equation number 1. If you substitute in equation number 1, what is the value of Q here? Q value is equals to CV, which is equals to what is Q1? Q1 value is C1V plus what is Q2? Q2 value is what? C2V. CV is equals to C1V plus C2V. Next step, CV, take V common here, we left with C1 plus C2. Next step, V and V gets cancelled, we left with C is equals to what? C1 plus C2, or else CP. What is CP? Total capacitance in parallel combination CP should be equals to C1 plus C2. When number of capacitors are connected in parallel, the total capacitance is equals to sum of the capacitance of what? Individual capacitors, which is the formula for effective capacitance or total capacitance of how many capacitors? Two capacitors which are connected in parallel. Suppose if n number of capacitors are connected in parallel, suppose if n number of capacitors are connected in parallel, then Cp should be equals to C1 plus C2 plus C3 up to Cn. So this is the total capacitance for n number of capacitors which are connected in parallel. So the last session we derived an expression for total capacitance of series combination. In today's class I derived the expression for total capacitance of parallel combination. In the next session I will come with detailed informations, some extra informations which are related to series as well as what? Parallel combination of what? The capacitors. As of now I will stop here only. We will meet in the next session. Okay.